Hi everyone, I hope everyone's doing well. This is Mrs. R here, and today we're going to talk about the empirical rule. You may have heard of the normal distribution before. Intelligence quotients, or IQs, measured on the Stanford revision of the Binet-Simon intelligence scale, are normally distributed with a mean of 100 and a standard deviation of 16. We're going to draw and label the diagram based on this information. Now, many tests that you take that are standardized, such as the ACT or SAT, sometimes they curve these tests based on the normal distribution, which is this nice curve here. Sometimes in different classes that you have, the professor or the teacher will curve an exam based on the normal distribution, where the very mean and median would be the center, the 70% C value, and then it would go on from there. So let's take a look at this example. A mean of 100. So in a normal distribution, the mean and median are the same. So we're going to put 100, and remember that symbol is our mean. The standard deviation of 16. As Mrs. Van Norman said, the standard deviation is the average distance from the mean. So we're going to take a standard deviation of 16 in both directions. As you can see, we're going to go both directions, positive 16 and negative 16. 100 plus 16 is 116, and 100 minus 16 is 84. Those are the IQs that are one standard deviation away from the mean of 100. You can see below in red, negative 1 standard deviation and positive 1 standard deviation. Remember that lowercase sigma is the symbol for standard deviation of a population. We're going to continue the pattern and go up another standard deviation, so a total of 2 standard deviations to get 132, added 16 twice from the mean, and then subtracted 16 twice from the mean to get minus 2 standard deviations to get an IQ score of 68. Lastly, we're going to do that again with plus and minus 3 standard deviations. We have 1, 2, 3 additions of 16 to get 148, and 1, 2, 3 subtractions of 16 to get 52. This would be what a normal bell curve looks like, a normal distribution for IQ scores with a mean of 100 and standard deviation of 16. For a different example, a university professor determines that the year's history exam results were approximately normally distributed with a mean of 62 and a standard deviation of 13. Once again, we can put 62 in the middle because that is the mean, and in this case it's also the median if the results are normally distributed like this. We're going to add and subtract 13 in both directions for 1 standard deviation. Then we're going to add and subtract 13 again, so a total of 2 additions of 13 on the right, 2 subtractions of 13 on the left to get 36 and 88. Those are 2 standard deviations from the mean. Once again, we're going to have 23 and 101, 3 standard deviations away from the mean in both directions, in the negative and positive directions. We got this by adding 13, adding 13, adding 13 from 62, subtracting 13, subtracting 13, and subtracting 13 from 62. When a dataset is normally distributed, you may apply the empirical rule to determine the probabilities of a score falling within that grade band or within that score range. This is showing us if the mean is in the center, you have 1 standard deviation to the left and 1 to the right. 68.5% of the data falls within that band. Within 2 standard deviations of the mean, 95.4% of the data falls within that grade band. Lastly, most of the data, the majority of the data, falls within 3 standard deviations of the mean, which is 99.7%. Now you'll see some different graphs. The one that we're primarily going to use is going to look like this, where 1 standard deviation from the mean holds 68% of the data. 2 standard deviations within the mean holds 95% of the data, and 3 standard deviations from the mean holds 99.7% of the data. Here's how we can use this rule, this empirical rule, when data is normally distributed. Using the IQ data and empirical rule, we're going to find these three probabilities. So here is our data for IQ. We're going to find the probability that a randomly chosen person has an IQ between 84 and 116. Well, if we look at this, 84 is 1 standard deviation away, and so is 116. So according to our empirical rule, we have 68% is the probability that a randomly chosen person has an IQ between 84 and 116. Next, we're going to look at the random probability that a person's IQ falls between 68 and 132. Those are both 2 standard deviations away from the mean. That will be 95% chance that a randomly chosen person has an IQ between this range. Lastly, we're going to look at where does 99.7% of the data fall on this normally distributed data set. Well, if you look, we know that 99.7% of data falls within 3 standard deviations of the mean. So on here, we can see that it's 52 and 148. Now you're going to go ahead and take the empirical rule quiz, and if you have any questions, please feel free to let your teacher know. Hope everyone's doing well and hope your families are safe and healthy.